The UN Climate Change Conference, COP25, has been taking place in Madrid. The purpose of the conference is to take the next crucial steps in implementing the global carbon-cutting proposals that were agreed upon 4 years ago in Paris. But where are we on the road towards a carbon-neutral future? And what's it going to take to get there?
My name is Eric Wolf. I'm a professor in the Department of Earth Sciences in Cambridge.
My name is Elliot Whittington. I lead the work for the Cambridge Institute for Sustainability Leadership around engagement between policy and business, which is a strong focus on climate change.
And I'm pleased to say both of you cycled to come and see me today, which is very laudable. How much CO2 did you save, Eric, by your cycle ride several miles to the back of beyond to come and meet?
Oh, I'm afraid I haven't worked it out in grams of CO2. It's fairly small, but it all helps.
Let's just back up very slightly. What actually is the evidence? Because a lot of the headlines that are coming out dwell on emissions. But what's the evidence that CO2 is linked to climate change?
Well, the first thing to say is it's not just estimates of emissions. We actually measure carbon dioxide in the atmosphere at places all around the world. And the carbon dioxide concentration really is going up. I think this year the average is going to turn out to be 410 parts per million. In 1800, it was around 280 parts per million, so that's an increase of nearly 50%. We know that carbon dioxide causes warming of the atmosphere, and we're seeing that warming. Temperatures have risen by roughly 1 degree Celsius since the Industrial Revolution.
The CO2 that we chuck out today, how long will that be active in the atmosphere? So even if I turn the tap off today, how long does the bath stay full for?
So unfortunately, it stays fairly full for quite a long time. So the good news is that some of the CO2 being put into the atmosphere goes into the ocean and into the land, into trees and soils. About 50% of it actually nature kind of takes away for us, and the other 50% stays in the atmosphere. Unfortunately, it then stays in the atmosphere for timescales of centuries and beyond.
And Elliot, where is most of this CO2 coming from? What are the major sources?
The number one villain that people usually talk about is coal. Oil is next on the list, followed by gas. Then you've also got sources associated with our land use, so degradation of soils and all of that kind of thing. But there's an inevitable conclusion to what Eric's been talking about in terms of the science of climate change, which is that firstly, we need to reduce. But secondly, we absolutely have to get to a point where the emissions are balanced by the things that are soaking up those emissions. If we can't get to that net zero position, we can't get to a position where we've solved the problem.
Because one of the things that people often say is, we need to stop emitting CO2, but we could, on the other hand, offset that CO2. So as long as we have a way of removing the equivalent amount of CO2 we've produced, we can still produce CO2. We just have to make sure that the actual amount isn't going up.
That is true in the abstract, of course. One of the challenges there is I don't think we've yet got a really solid view as to how to do that at the scale that would really offset significant emissions in the real economy.
The one thing I'm not seeing in the headlines, no one says population. No one seems to mention the fact that when I first went to university, there were 6 billion people on Earth. That was about 20-something years ago. There's now 7.5 billion people on Earth. So that number's going up, not down, and every single one of those people has a big carbon footprint.
Of course, that's true, and as long as everybody's going to have the same carbon footprint as we have here in Cambridge, for example, then a bigger population is certainly going to mean a bigger carbon footprint for the whole world. But of course, the whole aim here, if we're going to solve this problem, is that we've got to get to the point where everybody can have no carbon footprint. So you're right, again, in the abstract, but in practice, we actually have to solve both problems.
Doable?
I think it's doable. It's just very hard. You can paint a picture where we can look at how we reinvent power generation, reinvent transport, how we reinvent industry and agriculture. All of these things can be done. The technical solutions are out there. The policy systems are out there. Our challenge actually is not in constructing this new world. It's transitioning from our current way of doing things to a new way of doing things and doing that around the world in the course of a generation.
What's it going to take, though, Elliot? Because we heard a few years ago people saying, look, we're in trouble. If we carry on the way we're going, we will have irreversible climate change. And everyone said, this is ghastly. We must do something about this. Governments all around the world signed up and said, yep, we're right behind this. We're going to accept these targets. We're going to make a difference. I'm not seeing much action.
We haven't seen action that is coherent with the scale of the problem. But we have definitely seen action. Before the Paris Agreement, people were sort of saying we're on track for 4.5 degrees. After the Paris Agreement, if that agreement is implemented fully, we're down to about 3.5 degrees. We are bending the curve. Practical things like the number of coal-fired power stations in Europe, the US, China are far less than people predicted were going to be. So action is taking place. What we really need to do is vastly accelerate it.
What will be the consequences? If we do carry on the present trajectory, what do models predict?
If we carry on literally the present trajectory, in other words, if people don't even meet the commitments they made in Paris, then we'll end up with a global warming of about 4 degrees. If they meet the Paris commitments, it's more like 3 degrees. And
By when?
By 2100. And if people go and meet the Paris Agreement, then 2 degrees, maybe 1.5 degrees. The difference between those numbers is a lot. So at 4 degrees, the Arctic sea ice is definitely gone. The whole of the Greenland ice sheet, which contains 6 metres of sea level roughly, is certainly vulnerable, and part of the West Antarctic ice sheet as well. So then, potentially, with that 4 degrees, we're talking about committing ourselves to sea level rises of 5 to 10 metres. Well, there are island nations that have been talking a lot this week whose average height above sea level is 2 metres.
If one considers the impact it'll have on the average person's lifestyle in order to achieve the kinds of reduction in emissions that we're striving for, can you put that into practical terms for me, Elliot, in terms of what would I have to give up in order to do my bit?
A net zero economy could be a much more pleasant place to live than our current economy. Better designed towns, cleaner air, better diets. It is not the case that we should see a net zero economy as inherently hair-shirted and punitive. How we travel and how we eat are the things that will change most, but we can still travel places, maybe not quite as quickly and quite as far all the time.
Are you optimistic, Eric?
I'm reasonably optimistic in the sense that I can now see how it can be done. I'm a little less optimistic because obviously there are some countries that just aren't engaging with the process properly at the moment.
Like?
We can't deny that the United States is saying that it's going to pull out of the UN climate agreement. That's a worry that there's a country that for at least the next few years is not going to engage with the process because we don't have a few years. We can't afford to wait 10 years and then start the process because otherwise we won't make it.
Let's hope it doesn't come to that. Thanks very much to Eric Wolf and to Elliot Whittington.